going to take a quick look at trying to repair an Outback Power Systems power inverter offline and online system. I've had a few of these fail over the years. This seems to be the weakest link in the system. This is their battery monitor, the FlexNet DC. This one was purchased much more recently than the others that have failed, yet it still seems to have failed, I'm guessing, in the same way as the previous one. So I won't have to spend a lot of time troubleshooting if it is the same failure, because previously have found and fixed this same problem. The symptom is it simply won't power up at all. The easiest way to look for this particular failure is to set up to grab a multimeter, and set it on the diode check mode, because it's a diode that fails in this case. So the port that brings in or sends power out to the rest of the network is here. This is a category 5 RJ45. These are the connections to all the battery terminals, and the failure seems to occur right around here. If you take a look at the impedance of some of these components, you'll find that most of these diodes up here have a pretty typical 0.6, 0.7 volt drop, standard for most diodes. These two right here seem to have some resistance in parallel with them. If you put it in ohms mode, we see that they're both not too far away from a 470 ohm standard resistor value. So they're a little suspect, but may still be okay. But this one is, I believe, the one that has failed on me previously. This seems to be a design flaw, and that one is a dead short. So this is the diode that is closest to that RJ45. So we'll heat up the soldering iron, pull it out, and then test it out of circuit and see, just in case there's another component in parallel with this that provides that lower resistance, though I doubt it. It does look like the diode itself is shorted internally. Again, seems to be the weak link in this design. That diode doesn't seem to be designed to handle the current that it needs to handle. So best manufacturers actually publish specifications or schematics, things like that. They haven't really done that for a lot of companies in years, because they want you locked into them for repairs or replacement. In this case, the marking on that diode doesn't really give me a lot of information about who manufactured it or its specs. So I'm just going to use a basic silicon rectifier diode. This one's a 4007. It's rated up to 1000 volts. So if the thing failed for excessive voltage, this should more than take care of it. If it was a matter of excessive current, then it may or may not last that much longer than the original part. But I have had to fix these in the past and haven't had subsequent failures. I think this will probably do it. I'm just bending the leads down so we can get them to make contact. Got to observe polarity. We can see that this has the straight line on the LED symbol to the right. So we also put the line, the polarity marker of this diode on the right. We're going to put it on that way. Pre-tin these leads to make it a little easier to get in there. One thing to watch out for, make sure that the inverter is connected to port 1 and not any other port on the hub. That causes problems and reduces the functionality. Basic replacement. To clean out that little bit of loose solder nearby, and I think we're ready to try it out. And there it is, reconnected. It powers up and operates again as expected.